Hello, everyone. We are starting now. So, welcome everyone to our Drinks and Debates evening. It's a quite beautiful evening, and I'm very happy to be with all of you here. Thank you so much for coming. And I'm quite excited because I think we have great things to talk about today, and an amazing lineup. So thanks a lot, David, for moderating this panel, the Interoperability Challenge. After this one, we're going to have maybe 15 minutes of break. Then you guys can have some drinks and food. And then later, we're going to have the arbitration panel. We're going to talk about fraud proofs with Luca Dono moderating it. So I hope you all have a very good time and make good friends, have good conversation, and all the best. Good luck. We can start.
Thank you so much. All right, we're working? Great. Thanks, everyone. I'm guessing by the panelists and also by the title of this, everyone here is decently technical. It's kind of my vibe. Raise your hand if you disagree. Okay, one hand. That was one hand. Okay. I want to kind of slow roll into this conversation because we actually have a bunch of time, and thankfully this is like not a massive like amphitheater, so we get to have like an intimate conversation. So the title of this panel is the Interoperability Challenge: Security, Trust, Assumptions, and Convenience in the Modular Era. Which there's a lot there. Maybe before we even start defining the problem statement, which is going to like guide the rest of the conversation, I want to pick your guys' brains as your perspective of what you want to get out of this conversation. Let's imagine that the entire crypto industry is going to be watching this replay live on YouTube. Stop. What can the industry get from this conversation? How do you guys, what can we get out of this conversation to be most productive for this industry? Why is this conversation even important? So Ben, I'll start with you because you're to my right.
Probably a better understanding of what the interoperability problem or challenges are, how people are thinking about potential solutions, and also what the trade-offs are. So just sort of an honest conversation about that so people understand better.
And then also let's introduce yourselves as you go. So Ben,
I'm
from
Ben
Espresso.
Fish. I'm one of the co-founders and CEO of Espresso Systems.
Cool. Felipe?
Yeah. Hey, I'm Felipe. I'm one of the co-founders of Cartesi. And I really want this conversation to get us to better understand, as Ben was saying, the trade-off space between all these different teams. Because I don't think there's a right or wrong answer when you're talking about interoperability, convenience, security even. So it's a huge trade-off space that we can all learn how to navigate better. So yeah, that's what I hope to get from this conversation.
Prabal?
Hey, I'm Prabal. I'm one of the co-founders of Avail. I hope people who see it on replay get more confused about the different trade-offs. But jokes aside, I think we would all want the same, that developers know what kind of trade-offs are they making for on behalf of the users, that developers make informed choices, not by narratives, but by seeing the economic and the cryptographic guarantees which they will inherit by the protocol, and that's what I want to have.
Cool. And last, Daniel?
Yeah, I'm Daniel. I lead the developer experience team at Scroll, focusing on our kind of like yet to be announced Scroll Stack project. I think in our conversation, a lot of it will be revolving around the technical, but I think that there's also just a really big coordination problem that has to get solved if we're actually wanting interop and secure interop. And so understanding also maybe some of the challenges around that and almost like this political coordination context, I think is really interesting too. So.
Beautiful. And if the YouTube watchers and also you guys are also curious as to why we're all shifted down over here, it's because we're hiding from the sun, but the sun is moving. So if you guys want to like sneak down this way as well, since we're expanding our horizons.
It's still there, but
okay, all right. Okay. Next I want to actually define the problem statement. So like the interoperability challenge in the modular world. We like modularity because we get to focus on modules' core competencies. Modules get to refine themselves, be the best versions of themselves, but then also be meaningfully segregated from all other modules. And so there's a bunch of collateral damage that comes with that design choice, maybe to put it like harshly. maybe we could try to really define the problem statement here. Like, what is the problem that we are trying to overcome? And so let's go in the reverse order. So Daniel, I'll start with you. Maybe you can give your perspective on the challenges here.
Yeah, so I mean, the problem what we're trying to overcome is we're still trying to figure out how to make sure we're building these permissionless, verifiable, censorship-resistant systems, right? And so we all want to make these things. In the past, our choices have been to like either keep trying to like crank up a monolithic configuration or have multi-chain configurations and figure out good ways for those to talk to each other. But as you start doing this multi-chain thing, you start realizing, oh, every single one of these chains has certain elements, modules in common, and so then we can make abstractions and make companies, and then people can have an expertise in the sequencing layer, the DA layer, whatever else, right? So it's really nice that we get to pull those things out, but every time we pull that aspect out, we have to remember, okay, when we put it all back together, there are new security assumptions that are additive from each of these components, and we also have to consider like what what we're importing there, how that works together, and then I think the last thing that gets kind of messy, right, is that like what do we get when more people use the same components, and so there's like emerging features that can happen if there is the coordination around that.
Mm-hmm. Does anyone want to expand on that? Who wants to add color to the problem statement?
I think. Sorry, I just want to say that I completely agree with most of what he said. The only thing I think that what modularism also gives us is to choose between decentralization and whether they want to become permissionless, and we should not take that as probably a given in the modular space, because people might have different trade-offs. There might be a particular solution which doesn't want decentralization. They don't want censorship resistance. They want to build an app-specific chain for a particular jurisdiction, and they want to follow the rules, and that's fine. That should also be fine.
Mm-hmm. I think ideally we'd have more applications and use cases that could guide our infrastructure work. I think a big problem in this debate is that we're trying to do some guesswork of what kinds of applications we're trying to optimize for, but without having without really having these applications to guide. So we are, I guess, doing a lot of guesswork here on these components.
Mm-hmm.
So I have in mind a very specific interoperability problem that it sounds like maybe it might not be the same. So it's actually, this is good to have this conversation at the start. When I think about the interoperability problem, I'm thinking about when you have applications in different execution environments. So on, say, different rollups, then how do you get them to interact with each other? That's really easy in one execution environment. It sounds from your answer, though, is very interesting that you're talking about maybe an interoperability problem that arises from some people using this DA layer, some people using that DA layer, some people using, and maybe these are related to each other, but or maybe I just misunderstood. So I just
think
wanted
maybe
to
like
clarify.
I was trying to maybe answer the question not specifically in the context of an execution.
Yeah, so you're more
space,
more
just
generally
what is the
looking
modularity
at right. I guess you can view the problem of interoperability between users and applications on different rollups as a special case of interoperability between users and applications on stacks that have made different choices and aren't sharing the same infrastructure in general.
Yeah, and I think this is an extension of what we see all the time for developers in blockchain and crypto, right? You are developing protocol or you're developing application, and like both of these contexts have things that you could consider modular, hit different pieces of the stack, and
sure.
But
yeah.
But I don't think that the first problem you described, I guess we understand it a little bit better because we've been talking about it for a long time. So the interoperability between different rollups,
You
for
think we
instance.
understand it better?
I think the conversation is much more advanced than the conversation between the interactions between, say, data availabilities, optimiums, validiums, and execution layers.
Yeah, I actually haven't thought about whether using different data availability layers would at all interfere with interoperability or not. That's not.
Yeah, so I guess like in the case of fraud proofs, because it's kind of funny because in Cartesi, since the beginning, we were doing app chains, though we were calling them local consensus, which in hindsight is not a very good name. But we took all the trade-offs in favor of computational scalability instead of interoperability between rollups.
Mm-hmm.
And because of that, we have to do fraud proofs, right, which is the theme of the next panel. And the fraud proofs, they have a lot of components that that differ when you're using a DA layer rather than Ethereum, right? Because you have, for instance, the censorship guarantees of Ethereum are different than the censorship guarantees of Avail or Celestia or so on. And also like data publishing and the windows that interact between what's data being posted on Celestia or blobs coming to Ethereum. So I think that's a very hard problem that we're still trying to gather understanding in.
But also, just to add on top of that, like even when you publish to different data availability layers, the guarantees are varyingly different. Not because the data availability layers have different guarantees. That's of course one. But what if multiple rollups use the same DA layer, then the guarantees that come is that you get almost the DA guarantees for free. You have the single canonical ordering over which you can just verify execution proofs. On the other hand, if you have multiple DA layers, then you not only have to verify execution proofs, but also have to verify ordering guarantees. Now, to verify ordering guarantees of a DA which is outside your system, you have to rely on consensus rather than being able to rely on the same security. So there are varyingly different security trade-offs that you are making when you have different DAs and all, but also.
But this is not. I mean, we've dealt with interoperability between different chains for a long time, like different L1s, and so different L1s have different security assumptions and are using different. I mean, if you want to think about it like that, they're using different DA layers. So if we're talking about asynchronous communication between applications on different rollups that have made different choices of infrastructure, I feel like that's actually something that we've been working on for a long time. Whereas when it starts to get to looking at, can you do better than asynchronous communication when two rollups happen to be on the same L1, for example, that's a lot trickier and less understood. And it doesn't necessarily have to do with making like different security assumptions, but sort of more fundamental reasons about the things that rollups are trying to achieve by sharding execution and the things that are required for more synchronous composability between applications.
No, yeah, you are sorry.
No. So I do agree with you that if you're talking about the fringe of the interoperability debate, like asynchronous versus synchronous interoperability, then it's a problem that I don't think we understand very well.
Starting to understand it better.
Yeah. Thanks.
So I guess the main question is, what are we going to talk about here?
I think
we're all on the same page. I think this is the general contours of what I'm picking up on is that having different modules produces some emergent difficulty of accounting for the differences in these modules. And especially I think as you add more and more modules into whatever you're building, then you have more permutations of where there are disconnects. Maybe some disconnects are more serious and bigger concern than others, and maybe some are marginal. But nonetheless, this is kind of the cost of becoming modular. And I think this is why this conversation is getting unwieldy. It's because we're trying to define which module has an interaction with another module that is worth discussing, and then which module has an interaction with another module that is actually that's marginal, we can kind of ignore that. And so where this conversation is important is actually we have to literally unpack this one by one, which that's my take. Do you guys agree with that perspective?
Yeah, I think.
Yeah, I mean, if we talk about all the modules together, then I will win in the objective. It will be more confusing for the users. They don't understand anything.
Maybe we can make this conversation really clear, hopefully, if maybe one of you guys has an example scenario that we can bring to the table of when trust assumptions across modular components really breaks down. Is there a salient example that comes to mind for someone of when the world of modularity really needs to understand its trust assumptions under the hood?
Yeah, I mean, I think there are many. I mean, each one of us can probably talk about one example, but just for me, if you want to verify, if a user wants to verify the state of a rollup, then even with centralized sequencers which have forced transactions for censorship resistance, just having the guarantees of not only correctness of all the execution that can happen through optimistic or ZK or whatever, but also that the completeness of that all the transactions have been included is a tricky problem. And that is where different design choices come to the fray. Like, what are the assumptions that you are making on the sequencer? What are the force inclusion guarantees that you are going to produce on the protocol? What kind of provers or consumers of that do you have in the system? How much permissionless each one of them are? And those kind of things come. The more constricted you make that system, probably it gets much more easier to argue about. And that's why we see out there in the wild people going towards decentralization, going towards that, because it's not that easy. It's not that easy because the guarantees fall through as soon as you take one system which has been trusted and you suddenly remove the trust, you suddenly open it up.
So I have I guess a specific example just to make the conversation very concrete. So let's look at one of the most common ways that people move assets between chains as quickly as possible, and without getting a different version of the asset. And that's through liquidity providers or solvers. Sometimes people call them cross-chain intent solvers. But there is some party that receives a payment from the user on one chain, and then releases a payment to the same user on a different chain. So this is the easiest way, with using a liquidity provider in the middle, for a user to move, say, ETH from one chain to another. And there's many different protocols that do that today, even between different L1s. An example is like USDC has the CCIP bridge, right, between different chains. And basically, Circle is acting as a sort of a trusted party there. But Circle takes the risk that when it receives the payment on one chain, it needs to decide how quickly it can give someone USDC on a different chain. And it's interesting to see what decisions Circle, as a party here, has decided to wait for different chains. So for Solana and Avalanche, for example, it releases the funds very quickly. For L2s on Ethereum, for some reason, it doesn't release the funds very quickly. And that's interesting because some people actually may trust the sequencer of a rollup. Like Arbitrum, for example, it has never equivocated. Or Ed, has it ever equivocated? It's never equivocated. Yeah.
We have the man here.
So it's never equivocated. But on the other hand, you might argue that, well, if there was enough to be profit to take from equivocating, then if it's just one server somewhere, then maybe you could get hacked, right? And somebody could hack it, cause equivocation. That's similar to how other exploits have happened, like the Ronin bridge hack, etc. And in any case, this is an example of different trust assumptions. So the third-party liquidity provider has to decide how do I reason about the security of Solana, the security of Avalanche, the security of Ethereum, the security of L2s on Ethereum, to decide how quickly I have finality and how quickly I can release funds on another chain.
That was really helpful. I want to try and unpack this structure here that I'm seeing. So we have the trust assumptions of Arbitrum, you have the trust assumptions of Optimism, you have the trust assumptions of all these layer 2s that we're passing value around. And they have different... Ed?
Sorry, if I can jump in.
Please do.
Their policy is to wait until Arbitrum tells them that the transaction has finality.
Okay, so Arbitrum, the Arbitrum sequencer tells Circle's CCIP bridge?
Until an Arbitrum node they operate tells them. So the definition of finality on Arbitrum says that your transaction is recorded on L1 and that has finality.
Right.
So
They wait until L1 finality. Right. And so Arbitrum protocol tells them they have finality after Ethereum finalizes, so after 15 minutes. Yeah. Right.
Right. Okay.
But if Arbitrum were to change and say, we're doing finality after 10 blocks on Ethereum, they'd probably just follow your lead there.
A node in Arbitrum could just say, look, I trust the centralized sequencer won't equivocate, and it could give confirmation within a few seconds, but they don't do that today.
That's part of the protocol definition.
Right.
The protocol doesn't tell you you have finality until your transaction is recorded on L1 with
Right. So this is an L1 finality latency conversation, nothing to do with like Arbitrum design.
Well, Arbitrum decided to not tell you you have finality.
Oh, I see.
Until this is the case.
Okay.
I think we're bumping into another problem here, which is how crazy it gets. Because Ed certainly understands very well the security assumptions of Arbitrum. I do understand very well the security assumptions of Cartesi, but like once a user or a developer is operating on a execution layer Cartesi, on L3 on Arbitrum being sequenced by Espresso, then like how much does this developer has to understand, right? We do have to work a lot on education on that side. I guess this conversation might be helping
Ed,
a lot. But
Ed, come on down.
You should
come on down, Ed.
should get a microphone.
All right. If I can
Yes.
say one more thing about
Make sure your mic's on.
Yeah, okay, I think it is. I feel like as a protocol designer, I have a responsibility to tell a user that they have finality only when they actually have finality.
Right.
Right? So
Not
it's
shortcut
true.
a
Someone
user's
could make a
finality. Yeah.
different decision. Arbitrum could have done things differently, told users they have finality when there's still risk of non-finality, but we don't do that, and no one else should do it either.
Right.
And just to understand, in Arbitrum, that's after your 7-day
No.
fraud-proof
No,
window.
after
No.
15
Finality
This
is
that one, right?
what finality means on every chain, as far as I know, is that there is only one result that is possible, and every honest party can know what it is.
Right.
And that happens as soon as your transaction is recorded on L1, and that L1 recording has finality.
Right.
At that point, there's only one outcome possible, and every honest party can know what it is. So that's finality. That's at the speed of L1 finality.
But if the
Do you see the possibility of an Orbit chain, for instance, using different DA, and then you have like the data posted on DA and a blob string posted on Ethereum, and you have finality on the blob string, but not necessarily
Not at all.
finality.
Like
But even-
once you post it to the DA, that
Yeah, the
ordering
DA
is final.
Yeah. You have to
DA
have
can be
finality on the DA as well.
you got-
Basically, when you have finality on the DA, then you have finality.
if the sequencer for Arbitrum never equivocates, so if you trust the sequencer to never equivocate, then you could get finality immediately when the sequencer gives you a signature. So the only way that you would not get
I guess
finality is if the sequencer
I would put it
equivocates,
differently, right? If you may choose to act as though that's final, and what you're doing is betting that there won't be a reorg.
Right.
Now, there's only been one reorg in the entire history of Arbitrum 1, but nonetheless, I am not telling you that there won't be a reorg.
And if
So
you can,
if Arbitrum tells you it's final, then it's really final.
and if you can trust the sequencer for that, then you can trust it for many other things.
And I think this is posing two levels of the ability. Thanks, Ed. Thanks for coming. Please feel free to stay as well. Where you have like actual true pure finality, as in you cannot get any more final than a proof posted to the Ethereum layer 1. But then you have like another level of not as assured finality, but where some like wallet UX, some third-party company could take that risk to provide you a better UX.
And some of them do.
And some of them do. Right. So I kind of want to define this example that Ben, this was a great example. Thanks for bringing it up. So we have the Arbitrum trust assumptions profile, the Optimism trust assumption profile, like pick your layer 2, like all the layer 2s down the line, all these different trust assumptions. They are not equivalent, even though that they are all very strong, they are not equivalent. And so as a result, we have this conversation. But then we have CCI, the Circle Bridge. What is that called?
CCIP, but then you also have other protocols too, like Across, like others, and
Right.
there are bridges that will bridge very quickly away from Arbitrum, not waiting for what Ed
Right.
is calling Arbitrum
And
finality
they're
as defined by
taking
the
some
protocol.
risk
They
to
are.
also like kind of manage on the end user the differences in many of these layer 2s.
Yeah.
And so if there are meaningful gaps in trust and there's a service that needs to, it's so meaningful that there's value there, some service is likely to step in. We're seeing this with Across.
Yeah.
They're doing it. We're seeing it with Circle's Bridge. Where they're doing it. But then also, this brings us to the conversation of the Ethereum Layer 1 protocol, which is why I think Paradigm on Twitter, like Georgios and Charlie, I've been talking about, like, let's just juice up finality on the Layer 1 and juice up the block speeds so we can get quicker finality.
Or
so
juice
that
it up on Espresso.
or juice up on Espresso, right.
Yeah, so let me give a perspective on this.
Okay.
Sorry.
No, please, but you're part of this now.
The L1, okay, cool. The L1 protocol has notions of a block that's published, a block that's safe, and a block that's final, right? And any rollup should answer the question of which blocks are published, which blocks are safe, and which blocks are final. And those should have the closest meaning that you can manage to what that means on Ethereum. So if you say it's final, it had better be final, right? If you say it's safe, it had better mean, well, it's a little bit unclear what that means. What that means. What it means is I think that absent some like broad systemic failure, it will become final. And publish just means, well, gee, I hope we don't have a reorg.
Right. Right.
But you can also trade security for convenience in some
Right.
senses, right? So you get pre-confirmations.
But it's
and
also
that's
the
like
ca- I mean-
a much weaker security than finality. But I mean,
It's also the case on L1 that somebody can decide to act on a published block before it has finality, taking a risk that it might reorg.
exactly. Yeah.
Right? So it's the same kind of equation, right? And there are actors who will take that risk up to a certain amount of exposed value and then switch over. You know, we'll risk up to $1,000 on published blocks, but then after that we'll wait for finality or whatever it is, right? As a designer of an L2 protocol, you have a responsibility to be honest and straightforward and to make those terms mean what people expect them to mean.
Okay, so I want to go back to our problem statement of we are entering this world of modularity. We've meaningfully entered it. We've been there for a while. Modules are getting really strong. They're perfecting. They're becoming the best versions of themselves, creating these gaps of trust between the modules. And I'm seeing two patterns of places that this is being solved. Third parties are coming in and filling that gap because that's a service that they can provide. There's an arbitrage. There's a value that they can capture there if that gap is meaningfully large. Also, we can also increase the scope of the Ethereum layer 1 or the layer 1 in general to do more things faster at a quicker rate. These are kind of the two patterns that I'm seeing. Is that vibe with all of you?
Yeah.
Yeah? Okay, well that's lovely. I'm wondering if that accounts for like most of the trust assumption categories that there are in this world of modularity, or if we really just talked about like solving trust assumptions of like transferring assets across layer 2s. Like are there like a completely new set of categories that we haven't even unpacked yet?
I mean, there is a lot to unpack there. The question is extremely loaded. Yes,
Please
you
unload
can,
it for us.
yes, you can change the L1 rules to be more favorable to a particular application, but then it's always a trade-off. Like most of the things on technology is always a trade-off, right? So if you are like Bitcoin had this huge discussion about making blocks bigger, right? It's not that the protocol cannot handle it. It's not that there is not enough bandwidth, not that, but you are giving up something for the other, right? I mean, today Arbitrum can produce a 250 millisecond block time because they know the trade-off that they are making, that the sequencer can give attestations that quickly, and that makes sense for them. Now, if you want like instant finality, like single slot finality, and if you want 2-second block times also, I mean, I think there was some discussion about all of this recently, then you have to assume that there might be micro reorgs which can happen. It's not finality, right? So you cannot have these two together. You cannot have, and this is a typical dilemma in consensus system design, right? You can either have liveness, very high degree of liveness, or you can have very high degree of safety, but not together unless you go to a hybrid ledger, which means that you have to have liveness first and then safety follows, which is what Ethereum follows today almost.
Even if you wait for Ethereum finality, it's not finality. You can still have a fault in Ethereum. It's just that it's probably not going to happen because everyone's going to get slashed. So, and anyways, I don't think we need to go down the rabbit hole of this, but like in every consensus protocol, these words they're like the word that we ascribe finality to, it always has some assumption behind it. It always has some trust security assumption behind it.
Of course.
But I think
So there's a spectrum for everything.
You typically on the roll-up space, right? When we're talking about security assumptions, we're talking about whether we're going to inherit ones beyond the base protocol, right?
Right.
And so, like in the finality context, like
Ethereum is God.
Well, even on
I don't think
Ethereum-
we have to worry about finality being burned.
No,
and
but
gone,
even on
but
Ethereum, users make their own call to a degree on when they consider a transaction final, and they may take the risk of trusting something when it's gotten enough confirmations, even before Casper finality gadget actually.
But that is not
calls it
final. Then you are taking a
It's
bet.
not finality under the definition of the fact that people will get slashed.
It's not
because
finality.
I guess the difference is whether you
No,
use this as a
it-
technical term or like a
Finality
product term or
is
something.
in
right?
any
Right.
protocol. Finality is defined with respect to a certain set of assumptions.
But there's always that trade-off between like finality and convenience and security and decentralization, right? Like you can trust a central actor, like that can be slashable to give you a soft finality, and that's okay for many applications. So that's also a
Yeah,
a trait that
absolutely.
can
But
study.
then you cannot define that as finality. I mean, we have to then agree on
You
the
can
notion
define
of
it however
finality.
you want. Like,
Yeah, then
as
everything
long
is
as you
a-
state the assumptions clearly.
Then everything
right?
is a
Yeah,
meme,
yeah.
right? Then settlement is a meme. Why do you wait for the smart contract? Why do you wait for the fraud proof to arrive? Why do you need Ethereum to verify at all? You can just rely on that systems because, yes, you decide what you want.
Like true finality exists. We all agree with that, but not necessarily that true finality is the most important thing that an app should be paying attention to, right?
Sure, we can design systems that like don't need to wait for finality to do their thing, right?
Yeah.
So like one of these third-party bridges, they are saying, I don't need to wait for finality in order to unlock the funds on the other side because I'm going to take the risk and I'm going to pay, you know, the opportunity cost of locking up liquidity, and then I'm going to take the slow route but charge the user for the fact that I had to take the trustless bridge
Exactly, yeah.
that waited for finality at every step and never put the funds at risk. Like,
But if we make these trade-offs, and so like say you're an app that is making a finality trust assumption trade-off, and you are assuming finality sooner than the Ethereum layer 1 is giving it to you, then you constrain any other third parties building on top of you because they are now beholden to your trust assumptions.
Yes.
And so, which like maybe your trust assumptions are correct. Maybe you made a really good trade-off, and you are actually building a stable foundation for people to build on. But nonetheless, if you are competing with like Ethereum layer 1 finality that's adjacent to you, then you're competing on a different foundation.
but if you're building on the L1 and it can get reorged and it's going to modify your state in some way, then like you're not building on a firm foundation, right? So I think the idea is that no matter what, if you are going to make different trust assumptions on over here, you have to redesign your system to account for those differences in order to make sure that like everything remains safe, right?
I guess I'm speaking from the app chain perspective, so that question is a bit easier for me because I can say like an exchange, for instance, should wait for finality on Ethereum. But if you're running a game, then you don't necessarily need to do it, right? So it's about like the trade-offs you can take as a protocol or as an application.
Maybe we can talk about the ways where all of these like gaps in trust kind of get solved. And I have like a few different. Oh, sorry. Do you want to add something?
I just called them lies.
Lies. Okay. Yeah. These white lies.
If you make a promise you can't keep, then you're deceiving your users.
Right. Okay.
But
And that has nothing to do with the value, just to
No,
be
of course.
very sure, right? I mean,
Sorry,
Can't do
value-
it,
I
don't
think
promise it.
Right.
I mean, you can provide insurances up to a point. Yes, you can provide economic backing up to a point. Yes, but the protocol guarantees are protocol guarantees. If you want to rely on protocol guarantees, then you have to take one route. If you are okay with taking economic guarantees, you can take another route without saying about the economic guarantees of the L1 doing a double signing and all that. That's a separate issue
But
altogether.
why are you assuming that that's an unacceptable route?
I'm not at all saying that.
It's all
but
a matter of like you informing the user of what's going on, right?
100%. I think this conversation is a bit ridiculous because behind everything, there is a defined set of assumptions under which something will happen or not. So even what Ethereum calls finality, it means something specific. It means that unless 1/3 of the stakers of Ethereum get slashed, it is final, right? And so as long as you communicate to your users what exactly you mean by you can trust this is final, that is fine. There's a spectrum, and there isn't any magic behind what Ethereum calls finality versus what Solana calls finality versus what Avalanche calls finality, etc. There's always a precise way to characterize what you mean. Now, it's another question of dealing with end users who may not understand a full explanation of what this means. And so then you have to make some decisions on how to communicate that. And there's always lots of information when you communicate these things, right?
But isn't Ethereum the final source of truth? So even though Ethereum does have
Ethereum can fork.
if you do not believe on the crypto economic guarantee that Ethereum provides,
Right.
then you should not build a L2 on Ethereum. That's the baseline.
My perspective has always been that like whatever Ethereum says goes, because it is the ultimate foundation. It is the layer 1. It is the single source of truth. And yes, Ethereum can fork, but we really don't want that. And so like to me, it's like whatever is the state on the Ethereum layer 1, all applications, layer 2's shared sequencers that are above Ethereum are beholden to whatever the state of Ethereum is.
Many users of Ethereum don't wait for 15 minutes before treating a transaction as final. And that's perfectly fine because Ethereum has never had a reorg that deep, right?
I disagree that most users don't do that, because the idea there is that like if you're on the L1, you don't have to wait for finality, because your transaction, if it's on the state of the things before you, like 1 or 2 blocks, it can get reorged and it's all fine,
And
unless you're like, I'm walking away with a
have
car, right? Like
It's very, I mean, Ethereum hasn't experienced reorgs that deep. And so many users do treat a transaction as final. And other parties, I mean, solvers, for example, solvers treat transactions as finals by taking risk. Everyone's taking risk. Everyone's taking a risk trade-off. By using Ethereum as opposed to, using something else, you're taking the risk that Ethereum is secure. I think we're also kind of talking past each other a bit here, because I think that I think we can agree that there's the best thing to do would be to be, very precise to end users about the assumptions that they're making.
Yeah.
And that's challenging because, then you're going to send them an essay and they won't necessarily understand what it means. So I think that the difficult thing is figuring out how to make choices when developing products that communicate responsibly to end users what they should do.
I'm glad you called this a debate.
I think it's developers too, right? I think it's not
And
just end users, because developers have to think
and then
about
they communicate to their end users.
and
too.
they actually have to make reason about it, which gets even harder when we start thinking about the latency for all the finality steps at each point in time. And then once you introduce that latency, we get to then come back to maybe the topic of asynchronous composability and trying to think about how to make abstractions over that. But
I would actually argue that like users, if we're ever presenting users with like the asterisk of like, well, here are your trust assumptions, that we failed. That's not going to happen. They're not going to read it. That's basically a terms and conditions. They don't read those. And it's actually only developers where this is relevant for. Users are going to use their things. They're going to experience their experiences, and they're either going to be happy or sad. And it's going to be as a result of the systems that devs built and the tools that devs were given, which are these tools that you guys are all producing in the first place. I want to, without any further comments, I want to kind of like skip to the future where we solve this problem. What are like the different paths of, there are a bunch of them. Maybe we can simulate how some of these like trust assumption fragmentations, these lies that Ed like to call them, kind of get solved. And I see like a bunch of different paths forward. One is like increasing the scope of the Ethereum layer 1. Another is like the third-party businesses, like the Circles bridge across. I'll even introduce, like Hart gave me this idea of like, maybe your transaction settles incomplete on Ethereum, but with an intent, somebody gets slashed an equivalent amount of value. So a user who wants to send $20 from rollup 1 to rollup 2, maybe that transaction didn't go according to plan, but the market maker actually had a bond. And so the user actually got $20 in a weird way, but the user doesn't care. User is happy, counts. That's another path that I can see to solving some of these like fragmented trust assumptions. There's also code reuse. If we use more code frequently all the time, the security and hardness of that code becomes more robust. Developers can start trusting these foundations more. And even though there's still a gap there, that gap gets really, really narrow. There are a bunch of different paths here. Maybe we can like talk about simulate a future where these gaps in trust assumptions do get filled in. Like, what are the necessary steps? What do devs need to do? Who wants to take this one?
I mean, there will be plethora of these solutions. We have always seen that developers take different points on the trade-off space and offer different solutions to their users. And I think it will be more of the same. There will be solutions which would want to rely on whether we agree or not the finality. And then there will be some economic assurances over which the developers will give services. They can cover the costs. If they crumble under their own pressure of costs, then that gets doomed. People come and say that crypto is a scam and more of the same. That also will happen. And that's why I think as developers, we have the responsibility to call out when people do not explicitly talk about the trust assumptions. If we as a community of developers do not call out developers who are making reckless choices, then we collectively will bear the brunt of users whose funds will go corrupt. And that is the baseline, right? I mean, I'm not against giving economic assurances. I'm not against, having liquidity makers, giving all of this. I'm not against having, ERC type standards where all of us follow some certain standards and they are vetted and regularly audited. And like Open Zeppelin contracts are used left, right, and center right now, and people trust it. It's almost like a given, right, at this point. And that's fair. That is the way forward with different execution environments, like a Linux VM coming in, like a movement VM coming in, like another person coming in. It's going to create problems also, because with only a single virtual machine, it was easier. With different virtual machines, even without considering the types of problems in the prover, in the problems in the state transition function itself, even without that, there's a lot of due diligence that each one of the devs need to do about the others. It is going to be problematic, but hopefully we can come out and have standards, enforce them on top of each other, have constructive criticism, but that we have to do.
Yeah, I definitely agree that we should all be very, very honest about the trust assumptions, have them well documented, well proven, audited, and so on. But I don't see a reason, as you were saying, I guess, to stunt the design space so early, because we are unfortunately in a moment that we don't have many use cases guiding infrastructure. We're trying to build for the use cases that we imagine, but it's rare applications that are, we have rare applications trying to push the envelope of what is possible to do under a blockchain world, right? And I feel like when we have those applications, then we'll much better be able to understand what are the trade-offs that they're trying to accept or not. But as long as the trade-offs are well documented, well talked about, well spoken, and standardized, then which, by the way, I don't know if we'll have time to get into it, but it's one of my biggest worries with chain abstraction is that not all chains are created equal. So if the trust assumptions and the trade-offs are not very clear, then you're just creating a world in which users are going to get wrecked, and it's going to look bad for all of us.
Right.
Absolutely.
Yeah. I think, ironically, one of the best solutions to the fragmentation of trust is reconsolidation of like the frameworks that we use.
Yeah, but I think that I think that it's interesting. That's why I think it's interesting to look at the problem of interoperability in a system where there are slightly more homogeneous assumptions, right? And so between different chains and different ecosystems that are running very different consensus protocols, I think the trust assumptions are sort of less comparable in a way. But if you look at rollups on Ethereum, right, the trust assumptions between these different chains, okay, we have a few different flavors of rollups, okay, but even if you look within one ecosystem, you have many chains that are using exactly the same trust assumptions. Right. And yet we still have an interoperability challenge, and I think it's a little more interesting to look at the interoperability challenge of getting applications on those different chains to interact not only asynchronously, but more synchronously. And this gets into a hairy area where you fundamentally, if you have applications on different chains that communicating synchronously with each other, meaning they're passing multiple rounds of messages before settlement on the L1, then the full nodes of one chain actually don't know their own state, right? Because they're not executing full nodes of the other chain. And so that would introduce two possible routes, right? One, an added layer of trust assumptions where the full nodes of one chain are trusting a smaller subset of full nodes that are also running full nodes for the other chain. Or, and I think this motivates sort of, something that I'm really excited about, which is faster ZK proofs. If you can get really, really fast ZK proofs, then full nodes of one chain, even within an optimistic rollup ecosystem, right, can send proofs to another chain about their state, right? And I think that ZK proofs are getting much faster, and if we especially don't have the constraint of verifying those ZK proofs on the L1, but just verifying them by passing them between full nodes of different chains, this is something that will really realistically happen very soon.
Guys, this has been fantastic. I have learned quite a lot, so thank you for helping guide me through this conversation. I appreciate it greatly. And Ed, thank you for coming in and stepping in. That was really great. Thanks, guys.